I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 46. We are in our holidays unit. Cheryl, did we just celebrate a holiday?
Yes, we just had Thanksgiving.
Yum.
And now we have to go back to work and school and all those things after a 4-day weekend, which is,
Boo.
I know, not my favorite part of Thanksgiving, but I do like the days where I don't work on Thanksgiving and
Me
eating
too.
and hanging out
Mm-hmm.
and watching the parade.
Oh, the Thanksgiving Day Parade.
Do you watch it?
Sometimes. It depends. Some years I do, some years I don't.
Okay.
I enjoy some of the performances and the floats and things, but there's also a lot of ads. And I don't always love those, and I only have so much patience for them usually.
Yeah, that's fair. When I was in high school, I was in a couple Thanksgiving parades.
Not the one like in New York or wherever.
No, like in Seattle.
Yeah.
Locally, in marching band or in drill team or
Okay.
things like that. So
That's
I remember
fun.
being in parades. I think when I was a kid, I would watch them. It's been a while, but you and I were talking about aspects of Thanksgiving. And I
Mhm.
mean, the parade is kind of a classic one. And so
It is.
yeah, it's fun. There's probably science in there somewhere if you look hard enough.
Yeah, maybe we can make something up, just
Yeah.
kind of fit it in there.
Yeah,
Science only applies every once in a while. So. No, I think there's actually a really obvious place that science applies with the
Where's
parade.
that?
With the big giant balloons.
Yeah.
Like, you know what I'm talking about, right?
Yeah.
Snoopy or Pikachu or whatever from year to year, whatever they happen to be, those big giant balloons.
Yeah, they're huge.
They're huge.
Yeah.
Have you ever thought about why they can float?
Well, most balloons float with helium,
Okay.
but I feel like there's maybe not helium in these. And then
Okay.
some large things, like those like blow up things on your lawn, have like a fan underneath them that's like continuously blowing.
Yep. Do you
So
think those have fans that are continuously
no,
blowing?
I don't. But I've
Okay.
never thought about what makes them float. They're
Yeah.
just present.
They are. Well, and if you
Yeah.
think about it too, how big are they?
Big.
Like
Big.
multiple stories tall, usually
Yeah.
like not as wide as a city block, obviously, but like a couple of buses across,
Yeah.
maybe,
Mhm.
right? How heavy do you think that balloon material actually is?
Oh my gosh, it's probably a nightmare to fold. I worked at a camp for a while, so I got used to like folding up the blob or stuff like that. And oh my gosh, they
And
sink
how
just the
heavy does that end
material.
up being?
Yeah.
Right? So it's actually really heavy, and yet it floats up above, like way up above. And it doesn't look like it's having much trouble floating at all.
Yeah. Interesting.
Why? So you said helium. So why would putting helium in something make it float?
Well, Ryan, because helium is, I'm going to guess, less dense than our air.
Okay, what does that mean?
That it would rise, it rises more than our air does. And by dense, maybe that the particles are further apart. You can tell I'm getting less sure about the information. I've heard something about helium that like it rises more because I thought it was the density. There's something about like that gas compared to the gases that make up our air. Because it's not just oxygen.
You sure?
Yes, you told me on this podcast before. Yeah, and so if you put it like in a balloon, then it's going to go higher than our air. I'm guessing the same would be true if you put a gas that was heavier than our air, then it would drop.
Okay.
Yeah.
Why? Now you said You talked about density, then you also talked about lighter and heavier.
And I'm not sure if they're related. I'm guessing they're related.
Okay.
Is it if something's more dense, it probably weighs more
And why would that be?
because there's more stuff to it.
Okay. When you say stuff,
Per square inch or whatever, there's more uh, molecules in it, more something.
okay, per square whatever.
Uh-huh. There's more stuff per square whatever.
Okay, per square
Mhm.
whatever. And
Yeah.
why would having more stuff or less stuff cause something to rise or sink?
Well, it'd be the same as putting something in water, I guess. It's just like the substance in this case is gas.
Okay.
And so, like, the air is a gas, and if you put another gas that weighs less, it's going to go to the top. I don't know
But
why
why?
though.
Okay.
Like, I mean, I because gravity is a thing, but like gravity isn't like pulling down all air. Air's just around us all over the place.
Okay. What do you mean it's just around us? What do you mean?
Well, air is not just on the ground
Mm-hmm.
because so gravity's not pulling it all down. Like air is off of the ground as well, which means it's
Okay.
like in all of the space.
Okay. So gravity isn't pulling it all flat to the same level, is what you're saying.
Yes, yes.
Okay. Do you think gravity is pulling on the air at all?
I would guess so because when you go up really high, there's less oxygen at least.
Okay.
Like if you go on a hike really, up high, it's like
Mm-hmm.
harder to breathe. And that's a thing, is like altitude sickness. And,
Mm-hmm.
like, so I
What
know
does that have
there's
to do with
less,
gravity?
well, it's further away from the earth,
Okay.
maybe.
There's that lower confidence again.
These are a lot of questions I was not anticipating when we said we're going to talk about a parade. Um,
Uh-huh. You're like, there's got to be science in there somewhere.
yeah.
Yep,
So
there
is
is.
there helium in the balloons, or is this a side tangent we're on now?
Yes, they are filled with helium. You're not
Okay.
crazy on that regard.
Okay. Well, I was wondering if they were like a kite or something. Like if they just like you open them up and then like get some wind in them, and then they just have
Sure,
air and they're stay open because they're moving fast enough. They're not moving that fast. That's the only thing.
they're not, and they're not open.
Oh, okay.
Right? They're like 3D. They're all the way around.
Yeah, they're not like, well, I know I was picturing them being open on the bottom and maybe having enough air that it would keep them
Hmm.
inflated.
I don't think
But
they're
it
even
is
open on the
helium.
bottom. Yep, it's helium. Yep.
That's so no wonder there's a helium shortage sometimes. Do you know about the helium shortage?
I do know about the helium shortage. I
Yeah.
do. Yeah. As usual, Cheryl, you've got lots of really good ideas, and I just need to kind of help you connect them to each other to be able to understand what's going on.
Cool. I'm excited about that.
Yeah? Does it make you feel a little bit better?
Yeah, and I just didn't even know which direction we were headed of like kites or balloons or what was going to happen. So, yeah, I'm
Yeah.
excited.
All right. In order to start understanding how this works, we have to talk about something that may or may not feel directly related, and
Okay.
that is pressure.
Okay.
Okay. And you talked about how there's a similar thing that happens in the water
Yeah.
as happens in the air. And you're right. We're talking about pressure in a fluid, and both gases and liquids are fluids. So you can think about it in the terms of air, or if you want to think about in a lake or an ocean, whichever way works best for you to process,
Hmm.
the principles are the same.
Okay.
As you go, and I'll use water as an example here, as you go deeper in water, what happens to the pressure?
It increases.
It increases. Do you
Yeah.
know why?
Ooh, I would not be able to explain it. Like I accept
Yeah,
it as a thing.
sure. And that's okay. The answer is actually fairly simple. It's just not what you would normally think about. It's because there's that much more, let's say, water above you. The farther down you go, the
Oh.
more water there is above you that's pushing down on you.
Oh, like a weighted blanket.
Yeah, right? And
Okay.
like the deeper you go, it's like throwing on another weighted blanket,
Yeah. Okay.
right? Or
Yeah.
if this was a really dumb example that I thought of, if you had a whole bunch of books that were the exact same book, right? Identical book, and you put one book on your hand, and then you put another book on your hand, and then you put another one. As you add another book, it's going to feel heavier and heavier, even though each book is actually the exact same weight.
Yeah.
It's an identical book. You just have more
Mm-hmm.
books on top of you. Same thing, right? As you go down in water, it's the same material,
Yeah.
but there's more of it above you.
Okay.
The same thing happens in air because air is also a fluid. The only difference is we're usually near the bottom of the whole thing as opposed to near the top like we are with water.
Oh.
And so that's why like when you change altitudes quite a bit, your like ears can pop because the
Yeah.
pressure is changing. As you go up, the pressure is decreasing as there's less air above you.
Interesting.
You're like thinking about all sorts of other things
That's
now.
really cool.
Yeah. Okay. Is this part making sense?
Yes.
All right. So the next thing that you need to understand is that pressure in a fluid is actually in all directions. It's not just up or down.
It's side to side.
Because the fluid is like all around itself, right? So there's
Okay.
pressure up here, but it's pushing in all of those directions.
Okay.
Does that make sense?
Yeah.
And that includes up.
Okay.
There is some water pressure pushing up. And you know that because, again, if you put your hand in water, you can feel the water on the underside of your hand, just like you can on the top side of your hand, right?
Yeah, that makes sense. And it's
There's water
also
there.
hard to swim in any direction in water. It's hard to
Yeah,
swim down. So
exactly.
that would make sense.
Yeah.
Yeah.
Okay. So you've got water pressure in all of those directions, including pushing up.
Okay.
Okay. All right. So those are our first two steps. We're good so far?
Yeah.
Okay. Now, if you take something else, like a balloon or like a floaty or whatever, okay, and you put it in that, and let's stick with water for right now, but
A
you
pool
put
noodle.
a pool noodle, like a fun noodle,
Yep.
right? And you pull it in there, that noodle has a weight that gravity is pulling down on it.
Yeah.
Does that make sense?
Yeah.
Right? It weighs something. That's all that weight means is the amount that gravity is pulling on something,
Okay.
right? Based on its mass, right? But it's just that's the way we measure how much gravity is pulling on a thing is the weight of that thing. So that's a force going in the downward direction. But there's also a pressure going in the opposite direction, going up.
Okay.
Right? The pressure that's just in that fluid. If the pressure going up is greater than the pressure pulling it down, it will push it up and it will float.
Okay.
Does that make sense?
Yeah, like a pool noodle versus an anchor.
Exactly. And with an anchor, it weighs way more than the water can push up on it, so it sinks.
It's
Whereas with the
stronger.
pool noodle, it doesn't weigh very much. It's really, really light.
Yeah.
And so it doesn't have enough pull from gravity. It doesn't weigh enough to pull it down, so it floats because the amount of pressure from the water itself is greater than what's pulling it down.
Cool. Yeah.
Does that make sense?
Yeah.
Okay, so now we're going to take it out of the water and we're going to put it in the air, and we're going to do it with a helium balloon
Okay.
because it's the exact same thing. Air also has pressure in every direction.
Okay. Yeah.
Right? It has the greatest pressure closest to sea level because that's where the most air, like almost the entire atmosphere, is actually pushing down on us.
Yeah.
Right? If you just think of just a regular birthday balloon, a party balloon that's filled with helium, do you think it weighs very much?
No.
No, it doesn't, because helium is the second smallest atom in the entire universe.
Oh, it's the size of the atom.
Well, so this is where density comes in, and you brought up density.
Yeah.
And you actually got it correct.
Yeah, I did. Nice.
So density is the amount of, and you said stuff, which is actually a good thing. And then eventually I pushed you and you're like molecules. Yeah,
Yeah.
the amount of atoms or molecules in a
Hmm.
given space, in a given area. You said square something or other,
Yes.
right? Which is one way to measure that. So yes, it's the mass per unit of volume or the space that it takes up, the amount
Okay.
of mass, right?
Yeah.
And so like the number of molecules or the number of atoms. So if you have a much, much smaller atom, like helium,
Hmm.
in the same amount of space for a balloon, than if you have what you would exhale, right, which is going to be carbon dioxide and oxygen and a bunch of nitrogen, which are all larger atoms and like molecules, which are even heavier,
Hmm.
right? So those are much, so it's going to be a lot denser. So they're going to weigh more than the
Yeah.
helium is going to weigh less when it takes up that same amount of space.
Yeah.
Does that make
That makes
sense?
sense. Yeah.
And it weighs less enough that the pressure from the air going up actually pushes it up.
Interesting. So in Friends, when
Yes.
Phoebe said that she asked the question, have you ever thought about maybe we're not being pulled down so much as we're being pushed down? She might have, you could argue that she was correct.
I think you could argue that a component of what she said was correct because we are being pushed down by the air above
Hmm.
us.
Yes.
However, if we got rid of the entire atmosphere and left everything else the same, we would still stay on the surface because gravity would be pulling us down.
But we are both being pushed and pulled down then.
Yes, but the amount that we are being pulled is significantly greater than the amount we're being pushed. But yes, that is true. We are
That's
also being
really
pushed
funny. I've
down.
never thought about that before.
That Friends line or how helium balloons work?
The Friends line that it might be true. A
Oh,
little bit. A little bit true.
a little bit true.
Yeah.
Yeah, yeah.
That's so cool.
And now let's float along to your quiz.
I'm just going to go ahead and float along out of class and I will see you next week. It's going to be
Oh no, you're
great.
bumping along the ceiling. You can't get out the doorway. Apparently, you still have to take the quiz.
Oh no, I can picture that little balloon. It's very sad.
Alrighty, first question. Where is air pressure the greatest and why?
Closest to sea level because that is where well, it's the bottom of where the air is. And so it's there's more air on top, which means more of it is pushing down.
Great. What direction does air pressure act?
All.
All directions. Nice. What is density?
The amount of stuff per square thing. So the amount of atoms or molecules in a given space. In a space.
Yes, yes. And technically, it wouldn't necessarily be square because it's in 3 dimensions. It's a volume, and
Oh, and a
square would be an
cube.
area, but that's
Mm-hmm.
okay. That's I
Mm-hmm.
know what you mean. What causes a balloon to float up in the air?
Helium is less dense than our air.
Mhm.
And so the pressure, hold on, let me think about saying it the correct way.
Mhm.
The pressure on it to stay down is less than the pressure on it to go up.
Okay.
It's not really the pressure on it to go up.
It is the pressure pushing it
Yeah.
up. It is
Okay.
from the
Yeah.
air. It's not really the pressure going down, though. There's something else pulling it down.
Gravity.
Mhm.
But the pressure on it to go up is greater than being pulled down by gravity.
Yeah. Yeah.
Okay.
Yeah. Nice job.
Thanks.
That's tricky. All right, last question. It's a little bit of a bonus question.
Ooh, that's exciting.
We used to use hydrogen instead of helium
Really?
to fill like really, really big balloons or like blimps.
Oh, hydrogen blips.
Yeah.
I've
Okay.
heard of that
Yeah.
before, and it's never even occurred to me that
Yeah.
that means that. Okay.
Hydrogen is a smaller atom than helium.
Okay.
Which do you think would work better and why? Hydrogen or helium?
Well, I think hydrogen would work better because if it's even a smaller atom, then it would be even less dense than helium. So then I wonder if it would go up, like if you put the two balloons next to each other,
Mm-hmm.
would the hydrogen one go up faster than the
Mm-hmm.
helium one? Okay.
It would. Yep.
Would it also stay? Will that affect how long? Like, you know how balloons, couple days later, they're like hanging out midway
Yep.
and then eventually they're done. I'm
Yep.
assuming that the helium just like eventually doesn't stay like perfectly contained
Right, because
in
it's
the
so
balloon.
small. It's such a small atom, it
Oh,
can actually go out of the little tiny pores in the latex of the balloon.
wow. Okay.
Mhm.
So that's why like a Mylar one stays longer
Yes.
because it's harder to get through that material
Yes, exactly
than.
right.
Okay. So
Yep.
then does that mean that the hydrogen balloon wouldn't stay as long because it's even smaller
Potentially,
atoms?
depending on if it was, the same material that it could go out of. Yes, that could be a factor.
Interesting.
Yep. But there's another piece with this. Have you heard of the Hindenburg?
Yeah.
Do you remember what that is?
No, not really.
Okay,
Kind of.
kind of.
No.
No. So it was a German blimp that was filled with hydrogen
Okay.
and there was an accident. Hydrogen is incredibly flammable.
Oh, amazing. Great.
Have you
Good
seen the
plan.
video?
No.
Should I show you the video?
Yes. Please. And listeners should be reminded that if they are listening on our podcast channel, that you can head on over to YouTube because we also video record all of these. And whenever Ryan screen shares whatever his beautiful artwork or fun videos, fun might be a stretch if we're watching an explosion, then you can watch along with us on YouTube.
Okay, you ready?
Yeah.
Okay. Do you see that? It's a
Oh, there's
giant blimp and it's a
so
big
much
giant
fire.
fireball because literally the whole thing, all of the gas is burning all at once. And you can see the people down at the bottom. So you see how big that blimp is?
Oh my gosh, just the gas itself is
The
burning.
gas, well, yeah, and then it burned the material that was around it. You can see like the
Yeah.
frame left over.
Oh my gosh, that smoke is so black.
Yep.
That's
Yeah.
awful.
Yeah. So it was a huge, huge disaster.
Were a lot of people in it?
There were some people who were in it that died,
Okay.
unfortunately.
Wow.
Yeah.
Holy
So
moly.
yeah, they don't use hydrogen anymore.
Kind of like how we don't use mercury in
Hats?
thermometers
Oh, or thermometers.
anymore. Yeah.
I feel like it's a little less because I'm not so sure that many people actually got sick from mercury in thermometers, but
Okay.
yeah.
Interesting.
But yeah, so there you go. So
The more
that's
you know.
the more you know. Hydrogen is actually better if you want it to float more easily, but helium isn't flammable. So we use helium instead.
Yeah. Yeah, that's a good reason to do that.
Yeah, I feel like that's really
Yeah.
sensible. So we will leave on that incredibly valuable life lesson. Why don't you go ahead and back up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
Ah! The bell doesn't dismiss you. I dismiss you.